Okay, let's take a look at fundamental counting principle and geometric probability. So again, my last tab, go ahead and copy this down. Alright, so looking at the first example, how many outfits can I make with 2 pants and 3 shirts? So I've drawn the 2 pants, one's red, one's blue, and 3 shirts, brown, green, and yellow. So with the red pants, I can have red in that, or red in that. So the 3 options for the red. And there can also be 3 options for the blue. I can have blue with brown, blue with green, or blue with yellow. So there'll be a total of 6 options. So the fundamental counting principle says that if M occurs in M ways, and N occurs in N ways, then the event of M followed by N can occur in M times N ways. Meaning, if you have 2 pants followed by 3 pants, then they can occur 2 times 3, which is 6. While having a kitchen remodel, Kiera discusses options with the contractor. There are 5 countertops, so I'm going to go ahead and color things in as I go. 2 sinks to choose from. From the appliances, there are 2 brands in her price range. Lastly, there are 4 flooring possibilities. How many different kitchens can Kiera design? So remember, all you have to do is multiply all the different options that you have to get your total. So we have 5 countertops. This is a listening check. Circle example 2. Times 2 sinks. Times 2 brands. Times 4 floors. Giving us a total of 5 times 2, which is 10, times 2, which is 20, times 4, which is 80 kitchens. So there are 80 kitchens to choose from. Different combinations we can have. Alright, so we're going to move on to geometric probability. So example 3, our point is on GM. So this is our total space from G to M. So it doesn't matter that they've given us N and O. So from G to M. It's chosen at random. What is the probability of getting HL? So the total is G to M, and HL is what I want from H to L. This is a listening check. Put a box around example 3 and color it in. So probability is what I want over my total. So what I want is 10 minus 2, and in absolute value, meaning if it's already negative, it doesn't matter, it's going to become positive at the end. And then 12 minus 0 from G to M. So that's going to give me 8 over 12. So from H to L goes 2, 4, 6, 8. And G to M goes 2, 4, 6, 8, 12. So you can count it or you can subtract, but it's just easier to subtract. Alright, let's take a look at another example. Central angle is 60. What's the probability of landing the spinner all? Actually, I'm going to correct that. It's not F. We're going to correct that to G. So G, what I want is 60 over the total. The total in any circle is 360. Always simplify. 6 goes into the 1 over 6. Alright, take a look at another one. The central angle sector is 31 and the central angle in sector E is 38. Probability of not getting E or C. The listening check, color in P, not E or C. Okay, so what I want is not E or C. So the whole thing is 360. I'm going to subtract what I don't want. So that if I subtract what I don't want, I'm left with what I want, right? So 360 minus those 2 numbers will give me what I want because I don't want those 2 numbers, which is 291 over the total, which is 360. And it simplifies to 97 over 120. If we change the question to probability of getting E or C, the probability of getting E is 38 plus the probability of getting C, because we use the word or, is 31. So it's going to be 23 over total, which is 360, which simplifies to 23 over 120. The listening check, coloring 23 over 120. Alright, example 6. So it gets a little bit harder to count on these kind of things, so that's why sometimes you just have to use absolute value. What I want over total. So the total is from the whole segment line, so from negative 69 to 11. And then what I want is from negative 36, and you can see it doesn't have a negative 36, so it's somewhere in between there and somewhere over there. So it's a little hard to do this over a picture, so now we just use absolute value. So negative 36 minus negative 12 over the whole thing total, which is 11 minus negative 69. And the order of it doesn't matter. That's why we do absolute value. 2 negatives make a positive, so you're going to get negative 36 plus 12, and 11 plus 69. Punch that in the calculator, you're going to get 24 over 80. And again, it's positive because it's an absolute value. Absolute is always going to be positive. Now it simplifies to 3 over 10. The listening check, circle 3 over 10. Alright, this last one is more like an EOC question that you're going to find. Find the probability randomly chosen point lies in the shaded region, given the diameter is 8. So what can I do? If I know the diameter is 8, then the radius, which is from the center to any point, is 4. And so if I find the area of the whole circle with the radius of 4, which is pi r squared, so pi, and then 4 squared, which is 16 pi. That's the whole circle, right? And we want to subtract the square so I can find, what I want, which is a shaded area, right? So I need to find out how can I find this little square thing. Okay, well, I know that that's a triangle, so I can find the area of a triangle, which has a base of the diameter, which is 8, and then the radius, which is the height, is 4. So I'm going to find a half times base times height, which is a half times the base, which is 8, times the height, which is 4, which gives me 16. Now that's only half the triangle, so that half of the triangle is 16, and then the other half of the triangle is 16, so a total of 32. So to find the shaded area, which is what I'm looking for, I'm going to take the whole circle and I'm going to subtract the square that is not shaded, which again, remember, is made of 2 triangles of 16 and 16. So the whole circle is 16 pi minus 32, the 2 triangles, is going to give me 18.265. As a listening check, put a box around 18.265 and color it in. And then the probability of getting the shaded, what I want, the shaded. So I just found out that the shaded is going to be 18.265 over the total. Now the total circle, that area, is 16 pi. So probability of what I want, which is just the shade, which is 18.265, divided by the total, which is 16 pi. And that's going to give me 0.36, times that by 100, and you're going to get it in percent, which is 36%. So 36% is the probability I get the shaded region. And that's probably the hardest question that you're going to get in terms of probability. The big thing is just using what you know to find it. Probability is always 1 over total. Let's practice.